So, starting off Unit 2, we're going to talk about rationals. We also later have to talk about radicals. Radicals being roots, square roots, cube roots. And rationals being what? There's two F words in math. We did one this week during our test. Factoring. What's the other F word? Not functions. Functions is pretty easy. What's tough in math? What do you not like to work with? Fractions. Rational is a fancy way of saying fractions. Our rational function is a fraction. Note that our x is in the denominator. And our graph looks like this. Now, why does this graph look kind of weird like this?
I don't remember what that is. I forgot.
Well, rational functions has asymptotes and holes. First, asymptotes are the invisible line that your graph gets close. Well, the closer your graph gets to that line, notice how it kind of turns away from it. You can call this the Cootie line or the MC hammer line. So as you get close, it doesn't touch. Doesn't touch or cross. It has both vertical and horizontal asymptotes.
Did you say the Cootie line?
Cootie line. Oh, I don't want to touch you. Like, wow, look, ugh. And it's like, ugh. And it gets really, really close to this line. Trust me, verticals don't touch. Horizontals, they kind of do, but that's down the road. Lucky for you, we don't have to solve these until after spring break, so we'll have to double back up on this again. Likewise, with holes, we can actually calculate where the hole is, but that's after spring break. Just know that a hole is exactly how it sounds. It's a hole in the graph. Now, how do you get these assholes? Well, with domain and range, note, I think I may have to give you a refresh on domain and range. So let's see. Domain, are we talking about the X or the Y? X, very good. So I'm talking about what are all the X coordinates of my graph? So as we go from negative infinity, do I have any part of my graph here at negative infinity? No. Where does your graph start? Well, it starts at negative 4, and it goes all the way from negative 4 to 3. So notice, what did I do? I boxed in my graph going from the range coordinates. My graph is going from negative 4 to 3. Do you see any part of my graph outside the shaded region? No, that's the whole point of domain and range. It's boxing it in. So range is going from left to right. It's your X. Domain is left to right. That's your X. And range is your Y. So as I look at the range of this graph, what's this lowest value? I don't have any values down here. My graph doesn't start until I get to about 0.5. And where does it stop? All the way up here at 3. Again, notice how all of my graph now is in the shaded region from 0.5 to 3. That is the range. So the whole goal of domain and range is to do this. Notice this graph is completely boxed in with the orange and green. That is my domain and range. So as I look at rational functions could be all real numbers. Notice my graph goes all the way to negative infinity and all the way to positive infinity, except it cannot equal that Cootie line, right? It can't equal this vertical asymptote. Likewise with the range, it's going all the way down and all the way up, except for when it gets close to my horizontal asymptote, it veers away. So it's all real numbers except for horizontal asymptote. With this unit, all we need to do is figure out the domain of rational functions. With the domain means I need to figure out how can I find these vertical asymptotes. So let's begin. We know that rational function is a fraction. And what do you know about fractions where 0 is the denominator? What happens here? Well, let's go to our calculator. And I take a number and divide by 0, and what does it tell me? Error. You cannot divide by 0. Please don't say 0. You can do this. 0 divided by 9. That's 0. The top number is saying how much you want. The bottom number is how much you have. You can say, I want 0 students in my class. Does that make sense? Yeah. You can take 0 from a number.
So at the bottom you don't need
This is saying I need 9 students out of 0 you have. Can you ever grab 9 from nothing? No. You don't have anything. That's why there's an error. I don't have anything for you to ask for. Kind of like your bank account. You pull out $9 and it's like, oh, you got a 0 bank account. Bye. Well, we all know this actually works with debt and negatives, but just think if it did this, how much in trouble everybody would be if you couldn't overdraft. So, when that 0 is in the denominator, that's where we get our vertical asymptotes. That's where our graph is all real numbers except for when this happens. So as I look at this function, 1 over x plus 2 times x minus 3, what numbers for x will make this 0? So let's look at these one at a time. What plus 2 is 0? Negative 2, right? Just take this sign and flip it. Because you know if you add the opposite sign of something, you get 0. So negative 2 will give me a vertical asymptote. And what minus 3 is 0?
Plus 3.
Plus 3. Very good. So my domain is going to be all real numbers except for x cannot equal a negative 2 and a 3, where I have vertical asymptotes. Now we did factoring before this because, well, sometimes you may have to factor the denominator. I have 1 over x squared minus 9. What does that factor into? I'll give you a hint. It's a perfect square.
3.
I heard a plus 3 and a x negative 3. So this factors into x plus 3 times x minus 3. So here, what plus 3 will make that 0?
Minus 3.
Minus 3. Notice that I'm doing each of these one at a time because if this 0, any number times 0 is 0. And if I make this one 0, then it also makes this 0. And what minus 3 is 0? Plus 3. So my domain is all real numbers except for x cannot equal a negative 3.
I was do the same thing like we did with the other method. Like, see what goes into 9? Like that.
Yeah, you could do the other method. So it's basically, at this point, whatever works for you with factoring. Like you're on your own from here on out with factoring. We really won't be going over that too much. All right, number 1. My goal here is to find the domain, which we're going to start off writing the domain in set builder notation, which looks like this. I have braces. I'm talking about the domain, so I'm talking about all x values to where x cannot equal what? Am I concerned at the top at all? No. It's the bottom where fractions have a problem, right? The bottom cannot equal 0. 12 times what will make this equal to 0?
12 times. Well, I got 0.
0.
Well, I thought you said 12.
Just 12 times what equals 0? 0.
Oh.
Think of it this way. Take your denominator and set it.
Oh, no.
Take your denominator and set it not equal to 0 and solve. So 12 times x, divide by 12. X cannot equal 0. So my domain is all real numbers except for x can't be 0. Number 2, n squared plus 6n plus 5 over n plus 2. Do I care about the top?
No, the bottom is the one that's random.
Exactly. I don't care about the top until after spring break. The bottom one is the one that matters. So let me set this n plus 1 not equal to 0 and solve for n. So the domain is all real numbers to where x cannot equal what value? Very good. So subtract 1 on both sides. N cannot equal a negative 1. Or look at these terms. What's the opposite of plus 1? A minus 1 would make that 0. Number 3 requires a little bit more work because I have to factor the denominator. So what does m squared plus 4m minus 21 factor into? Got my m, got my m. Looking for two numbers that multiply to a negative 21, add to a 4.
We said plus 4?
Yes, multiply to 7 and 3. One of these has to be a negative. Which one? 3. Because this is my plus, So the largest number has to be a plus. So that factors into n plus 7 times n minus 3.
What is that? What is that on the equals in that line called? What is that? What is that called? What is that called?
This not equals.
Not equal. Oh.
Yeah, that's your not equal. So my domain is going to be x, where x cannot equal what values? -7 and +3. Did you see where he got that?
Yeah.
Take the opposite of these signs, right?
Okay.
-7 plus 3.